Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you out with section or module 16.5 under applications of exponential and logarithmic functions here. So the first example we're going to talk about here is compound interest. And I'd like to walk through a quick numerical example with you. Please follow along here. So imagine that we start with $100, and I'm going to call that P sub O, which stands for your initial principal. And imagine that gets invested at 10%. Now, what that means is that after 1 year, you would make an interest of 10% on that $100. And that's a pretty easy calculation. I did that right here, 100 times 0.1, which is 10 bucks. And then after that 1 year, you would have, your new principal would be $110. Now, the next year what would happen is you would apply the 10% to that quantity, right, and so forth. Well, for the rest of this discussion, though, we're gonna kind of break this down into a monthly deal. What's happening each month? So we go back here and say, all right, we've got $100 invested at 10% interest, and I'm going to walk through what would we have after 1 month. So the way interest works is that if you get 10% per year, the amount per month would be 1/12 of that. So the interest that you make would be this expression right here. It would be 100 times 0.1, our interest rate, over 12, because we're talking about over just 1/12 of a year. And then our new principal would be our interest plus our beginning principal, and we would have $100.83. And again, this is after 1 month, right? Now, the next month goes by, right? And we're going to earn some more interest. We will earn this amount, 0.1 over 12, times our new value. So we'd have 0.1 over 12 times this 100.83. The new amount we have is going to be 100.83 plus the interest that we make. That's going to be 101.67. And then another month goes by. The new amount is going to be our old amount plus the interest we make on that amount. And then we're going to have 102.52. Right? If you kind of look at what's happening here, right, interest-wise, monthly, we're taking our initial principal, we are adding a little bit of interest. Next month goes by. This is now the new amount. So the next month, we're taking our new amount and then multiplying by our interest rate again, and so forth. The next term would actually be, if I wrote it out, the next term would actually be this entire thing times our interest rate. So then I put kind of a dot, 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 dot. There's kind of a shorthand formula that will calculate this. And when you look in your book, I think they call this the compound interest formula. In the compound interest formula, I've got it written right here, that your principal that you have at any given time, if you follow all the way to the right, is equal to your starting principal plus this quantity 1 plus I to the n, where what I'm calling the P sub O is the original amount. And I noticed after I wrote this all out that the equation in the book puts an A there. So I put a little, I'm going to let A equal P sub O. It doesn't matter if you put an A here or a P sub O. Put whatever you want. The important thing is knowing that this is whatever amount we started to invest. Okay, the I here is the monthly interest rate. You will get that by taking the, I guess what I would call the total rate and dividing by 12. And then the n here is the number of periods. So for 3 months in this example, n would be 3. For 1 year, n would be 12. For 2 years, n would be 24, and so forth. And that's how compound interest is calculated. So I'm going to go through the example here that's in your book here on 16.5. So it says, let's see, use the compound interest formula. And I'm going to write it P equals P sub O times 1 plus I to the n. I know it says A, but I can't help myself. Principal, initial principal, makes more sense to me. Where A is the original value in the investment, I is the interest rate per compounding period, n is the total number of compounds. So in the example here, it says an investor deposits $8,000. They're earning 12% interest. Let's see, compounded semi-annually. Semi-annually, I would say that semi-annually means twice a year. Now, in my previous example, I was doing compounded monthly. That's perfectly fine. Sometimes you can do monthly compounds, you can do twice a year compounds, you can do daily compounds. Semi-annually means twice per year. And that means that when we write this formula out, the principal is going to equal $8,000 times the quantity 1 plus. Now, the I is the interest per compound period. For twice a year, that's going to be 0.12 over 2. And then times the number of compound periods. And in this case, it says that what is the value of the investment after 4 years? Now, if 4 years go by and we are compounding twice per year, the number of compounds would be 8. So now I'm going to go ahead and calculate this. Most of these types of problems are compounded monthly, and I'll probably make some examples up that look like that, but I'm going to run this one as I read it. Okay, so 8,000 times the quantity 1 plus 0.12 over 2. And then we're going to raise that to the 8th power. And I get $12,750.78 out of that. So this person has done pretty well. Well, 12% is a pretty darn good interest rate here, and we're talking about after 4 years. So, yeah, they made some money there. So the purpose of this video was to help at least give you some sort of sense for where this formula comes from and how to apply it. Hopefully I've done that for you. I'll make up some more examples here that help. Have a great day.